All right, let's apply our understanding of logarithms to pH. Remember, we can have water naturally dissociating into hydronium ions and hydroxide ions. And it does that at a rate of 0.0000001 moles per liter. At any one time, we have about 1 times 10 to the negative 7th moles per liter of hydronium and hydroxide. So if we want to use logarithms to get a simpler number out of this, then all we need to do is say negative log of the concentration of whichever one we're hydronium. Negative log of the concentration of hydronium ions, so H3O plus, will give us our pH. So this is the equation we're going to be playing with. Next week we'll actually start to practice using it. But for now, what this looks like is I would plug in negative log, and then I would put 10 to the negative 7th in there. 10 to the negative 7 will give me 7. So the pH of water is going to be 7. That's why 7 is a neutral pH, because it's where these two ions are perfectly balanced. So why do I have this negative right here? Well, notice this guy right here, that's a negative 7. Just to keep the negatives out of the scale, we use a negative log. So we're just trying to get a nice, simple, crisp number that we can use here. So in our other example, we were saying, what if I added hydrochloric acid to the water? Well, that hydrochloric acid is going to react with the hydroxide ions and reduce them, as well as adding more hydronium ions. And so we would increase our concentration. Well, at neutral, we have an equal concentration of hydronium and hydroxide. Both of them are going to be at a concentration of 10 to the negative 7th. So our pH would be 7. And then our we could also say pOH if we wanted to track the concentration of the hydroxide. It's just the other side of the coin. Same thing. That would also be 7 in the neutral compound. That's just a way to say, hey, I have 1 times 10 to the negative 7 moles per liter of each of these things. So pH is 7, pOH is 7. That's what we're saying. If I wanted to add that hydrochloric acid, let's start over. Let's put a right there. There we go. If I said HCl plus H2O, that would give me a lot more hydronium ions. Because every single one of these little hydrogens that reacts with one of the hydroxides that's naturally in the water, that is going to reduce the concentration of the hydroxide and increase the concentration of the hydronium. So that's all we're looking at right now. We're just looking at how do these concentrations get affected. So when I do that, let's say I increase this by 10. So I say this started out, let's use a different color. This started out at a concentration of 10 to the negative 7, and this started out at a concentration of 10 to the negative 7. And I'm adding enough hydrochloric acid to shift this up by 10. So then this is going to become 10 to the negative 6. 10 to the negative 7 times 10 is 10 to the negative 6. Don't believe me? Put it in your calculator. Good to go. At the same time, that would reduce this by a factor of 10. 10 to the negative 7 divided by 10, that's going to be 10 to the negative 8. So what would my pH be at that point? Well, let's plug it in. pH, we find pH equals the negative log of my concentration. So 10 to the negative 6, negative log of 10 to the negative 6 is going to be 6. my pH becomes 6. Nice and simple. There we go. If I wanted to track my pOH, well, pOH is going to be equal to the negative log, same thing, but of the hydroxide concentration. So that would be now notice something here. This is going to be true in all cases. 6 and 8, what do those add up to make? These two together make 14. When I had -7 for my concentrations, well, then those added up together to make 14. When I add my pH and my pOH, when I add these together, so if I say pH plus pOH, I'm always going to get 14. That's why our pH scale goes up to 14. It's 0 to 14. 7 is neutral. 14 is the most basic we can get. So the highest concentration of the OH. 0 is the lowest concentration we can get, which means the highest concentration of H3O+. And add them together, you will always get 14. Now, it is possible to go outside that scale, but it's got some pretty ridiculous implications. So we're not going to worry about that. So next week, we're going to focus on actually practicing these calculations. So it might seem confusing now. That's okay. And tomorrow, we're just going to do a review of the things we covered this week.